Today we're going to take a look at the ESP8266 802.11 BGN Wi-Fi module, which is available here. It's several shapes and sizes. Some have got external antennas, some have got multiple GPIO ports, but the one we're going to take a look at today is the version 1, which is this one shown here, which has 2 GPIO ports. I've got the Lua firmware installed on this one here, and I'm using it as a web server in a matchbox, powered by a small button cell battery. The 2 LEDs you see here are connected to the 2 GPIO ports, and first things first, if we look at our Wi-Fi connections, you can see that the Equinox SID is being broadcast, which is my device. If I connect to the Equinox SID, and then if I go to a web browser and browse to the IP address of my module, which in this case is 192.168.4.1, it should bring up a web page which has been sent from the web server there. It's got 2 on and off buttons which are connected basically to the 2 LEDs, and if I click on the on and off buttons, I can toggle the LEDs on my little web server on and off. All in a little matchbox. The first thing you'll notice is that the way the pins are laid out, it's not breadboard friendly. So with all the will in the world, you're not going to be able to plug it into your breadboard in any useful way whatsoever. So we can either build a caddy for the module to sit into, or we can use just male to female jumper cables, which is what we're going to use here. Another thing is that the supply voltage needs to be 3.3 volts. So we're going to use a little regulator here to supply that voltage. I've soldered some legs on our regulator so we can plug it into our breadboard. We need to provide between 5 and 9 volts to pin 3 of the regulator, and we need to provide a ground to pin 1. And we're also going to use a 22 microfarad capacitor between pins 1 and 2, which are the output pins of the regulator. And that is basically the power supply. And if we measure the 2 pins across the capacitor there, we should see a reading of about 3.3 volts. So if we check that, 3.27, which is good enough. So that's our power supply sorted. Next, we need to plug some jumper cables onto our module itself. So we're going to use a black cable connected to the bottom right pin, which is the ground of the module. We're going to use a red cable for the top left pin, which is the power supply for the module, which is 3.3 volts, remember. And the second pin up on the left from the bottom is the chip power down pin, which also requires 3.3 volts. So those 2 cables there are to 3.3 volts, and the earth cable there, that's the power that we need for the module. The next 2 pins are the data pins. Looking from the bottom, the top right pin is the receive data pin. We're going to use a blue cable there. And the bottom left pin is the transmit data. So we're going to use a white wire for that. The only other pin we're going to connect here is to GPIO 0, which is the second pin down on the right. Now when we come to flash the firmware, we're going to need to connect that to ground. Other than that, we can leave it loose. So there's the pin outs there. Now you can use one of these little serial UARTs, which quite a number of them do supply 3.3 volts, but I think you'll probably find that the current just isn't good enough to power these modules, so we found them quite unreliable to use. But if we were going to use it, we need a ground pin which goes to our ground pin of our regulator, the blue wire which is receive data from the module connects to transmit data from the serial UART, and the white wire which is the transmit data connects to the receive data of the UART. Again, with the Arduino, that also has a 3.3 volt supply, but we have found this unreliable to power these modules, so we're not going to use it. We do still need to connect a ground pin which goes to the ground pin of the regulator, and the blue cable which is receive data goes to pin 0 of the Arduino, which is labelled up as to receive data, slightly confusing, and the white cable which is connected to the TX of our module connects to pin 1 of the Arduino, which is from TX, is labelled up on the Arduino. So now finally we need to just connect all our power leads onto our regulator. So there's the earth from the SP module, there's the red VCC power supply cable from the module, there's the chip power down cable from the module, and that's the ground pin from the Arduino, just to make sure we've got good earth everywhere. And that's how we connect the USB serial port if we were using one of those, and that's how we connect the Arduino, which we are going to be using. Okay, first things first now, we need to upload a blank sketch onto our Arduino, because if it's got any software running on it already, it may well interfere with our serial communication. So when you first launch your Arduino, some versions do automatically have the blank sketch ready for you to upload. If not, if you go to File, Examples, Basics and Bare Minimum, that is your blank sketch which you need to upload. So if we just check our board is set correctly and our port is set correctly for our Arduino, and then we click upload, and that uploads the blank sketch. If you have trouble uploading, disconnect the serial cables that you've got, and that should solve your problem. If we run the serial monitor and check the baud rate, is 115200, which is it seems to be the baud rate that all the new ones come in at. If that doesn't work, you can try 9600. They're the two common ones that appear to be loaded onto the modules, and their behaviour there we've set to carriage return. Now if we power on the module, we see a little blue flashing light, and on our serial monitor when we power on, we see a bit of preamble, and then we get the word ready. Now we just need to check two-way communication, so if we type AT and press return, we get an OK sent back, which is all good. If we type AT plus GMR and press return, it will return the version of the firmware which is on there already. So if we now open our Internet Explorer window, and if we do a search for Node MCU Flasher, and the top result there is GitHub Node MCU Flasher, which is where we want to download the flasher from. And if we download the zip, which is on the link in the right hand corner there, and save that, this flasher's pretty good. There are several flashers out there, but this one does everything you need it to do, so I recommend using this one. If we open the zip file, if we copy the contents of the zip file, on my C drive I've got an ESP8266 directory, so if I paste it in there, and if we go into the directory, and there's a Win32 and a Win64 directory, depending on what version of Windows you've got. and a release subdirectory, and then there's the ESP8266 flasher.exe. If we run that, and that will bring up the software. If we click on the advanced tab just to check, restore default will be fine. The config tab, now this is where we load our firmware. If we click the little cogwheel there, and if we browse to the directory where we've got our firmware, and there we go, the AI 0.9.5 AT firmware, open that. The memory offset, which is the OX0000, needs to be set. Now check that our COM port's right. We need now to connect GPIO 0 to ground, and then power on the module, and if we click flash, the progress bar should start moving, and on the actual module itself you'll see the blue light flashing, and when it finishes we get a little green tick in the bottom left hand corner there, which is all good. So we now remove GPIO 0 from ground, and if we go back to our Arduino software, and if we run our serial monitor again, and now because I've flashed the AI 095 firmware on there, I know that I need to change the baud rate down to 9600. So I've done that. If I then power on the module, little blue light as it powers up there, and again bit of preamble, and we get a slightly different screen, but we still get the ready signal. So if I just type 80, and we should get the OK. So all is good so far. If I type 80 plus GMR, I should get the firmware version. As you can see, that's changed, slightly different than it was before. So if I want to see what mode my module is set to, if I type in the box AT plus CW mode question mark, it returns there. We can see it's in mode 2, which is AP mode. So I want to change that in fact to station mode. So if I type AT plus CW mode equals 1, it should turn it into a Wi-Fi station. I've got an OK, so all is looking good so far. And in station mode I can list the access points it can see. So AT plus CW LAP will give a list of access points. There we see there are quite a few in my area. The first number there inside the brackets is the encryption type, so it's going to be either open, web, WPA, WPA2, etc. So that'll be a number 0 to 4 to signify that. The second, after the comma, the second bit of data is the SID. After the comma, the third bit of data is the signal strength, and after the comma, the next bit of data is the MAC address, and another comma, and the final bit of data is the channel number. So you can see it returns a fair bit of information. Now if I want to join one of the access points, I can type AT plus CW JAP equals the SID, in this case it's Equinox, and then a comma, and then the password, which in this case is so secure, is 12345678. Press return, and after a small amount of time I should see an OK come back. OK, there we are. So I'm now joined to my access point. So if I type AT plus CIFSR, that should return my IP address, and it should return my MAC address. So that's the IP and MAC address of my little module now that I've joined my AP. Now if I open a command prompt I should be able to ping my little Wi-Fi module. So if I ping 192.168.1.1, there we go. And that is my little Wi-Fi module. Now if I just check the ARP table, we can see 192.168.1.1 in there with the correct MAC address. Okay, that's about it. That just shows you how to flash the AT firmware and how to use a few of the basic AT commands. Thank you for watching. For more information and download links, please visit our website. Thank you.